As we start moving past equations with just a single step, we get into multi-step equations, two-step, and ones that even require more than two steps to solve. So there are certain things we want to start looking for in equations to solve with more than one step. And those are things like using the distributive property to remove parentheses. You should look for that. We should look for combining like terms on each side of the equal sign. And if we have those things taken care of, we can start looking for using addition or subtraction to zero out any numbers on the same side with the variable. And usually with multiple step equations, the last step we tend to have is solving for variable, usually by divide or multiply. So let's look at some examples. For example, if we have 2x minus 5 equals 71, we're looking for distributive property. There's no parentheses to worry about. We're looking for like terms. Well, 2x and negative 5 are not like terms. 71 is only a single term, so no like terms to combine in this problem. Next, I want to look for getting 2x by itself. Well, what's on the same side of the equal sign with 2x? Minus 5. Then we're looking to use inverse operations. So the opposite of minus 5 would be to add 5. So I want to add 5 to each side of my equation. On the left side, when I add a negative 5 and a positive 5, they're inverse operations. They zero out and leave 2x. And on the right side, 71 plus 5 gives me 76. Now what's being done to x? Well, x is being multiplied by 2. So we want to do the opposite of multiply by 2. We want to divide by 2. If we divide the left side by 2, we need to divide the right side by 2. And 2 divided by 2 is 1x or x, and 76 divided by 2 is 38. And if we put 38 back in the original problem, it will work for x. All right, let's try a new one. Let's try 4a plus 7 equals negative 49. We don't have any distributive property. We don't have any like terms, so we're looking to start by getting 4a by itself. So I can ask myself, what's on the same side of the equal sign with 4a? Plus 7 is on the same side, so I can undo that plus 7 with subtract 7. Plus 7 minus 7 zeroes out and leaves 4a on the left side. And then on the right side, I have an integer problem like negative 49 minus 7, which would be the same as negative 49 plus negative 7, or negative 56. Now I'm down to 4 times a, and I want to undo multiplying by 4 with divide by 4. If I divide by 4 on the left side, I also divide by 4 on the right side. Then I have a negative divided by a positive, and a negative divided by a positive is going to be a negative answer. 56 divided by 4 is 14. So a equals 14. So see how my equations line up and make this nice like railroad track, how I can see that I'm doing the same operation on the left side, on the right side, and they all line up. So neatness does count. Neatness will make this go much better. You'll drop less signs. You want to work these up and down. I know some of you guys like to write along a single line. Writing across a single line is not going to help with more and more steps. You really need to write these up and down. All right, let's look at a new one. We have 14 equals negative k plus 3k minus 2. I don't have parentheses for distributive property, but I do see some like terms. I have a negative k and a positive 3k, and I can combine a negative k and a positive 3k to get 2k. Then I'm looking at isolating the 2k, so I can get rid of this minus 2 by adding 2 to each side. Minus 2 plus 2 will leave 2k. And over here, these are technically like terms. 14 and 2 add up to 16. Then to undo 2 times k, I would just divide both sides by 2, and k would equal 8. All right, you guys pause the video. Try this one here. We have negative 3y minus 4 equals 11. Then come back and see how you did. All right, so we'd start this problem with adding 4 to each side. 11 plus 4 is 15. Negative 3y equals 15. I can divide both sides by negative 3 and get y equals negative 5. Now, some of them are given in kind of a different order. This one looks a little unusual because I have the t over 2 and the plus 3 in the front, but don't let this order confuse you. We can still start by isolating this t over 2, or t divided by 2, by subtracting 3 to each side. And when I subtract 3 to the left side, that'll just leave t over 2, which is t divided by 2. and 35 divided by 3 is 32. To undo divide by 2, I want to multiply both sides by 2, and you can do that with showing the dot or showing parentheses, but somehow you need to make notation that you're multiplying both sides of your equation by 2, and we get t equals 64. Now, this is an unusual problem to see. We have 3/4 x equals 21, and we see this throughout math, and here's a shortcut that will help you. Every time you run into a fraction in front of a variable, you can always get rid of it by multiplying by the reciprocal or the inverse. So the inverse or reciprocal of 3/4 is 4 over 3, and every time we multiply a number and its inverse or a number and its reciprocal, we always get 1. So 4/3 times 3/4 gives me 12 over 12. 12 divided by 12 is 1, so we get 1x. So that happens every time we multiply by the reciprocal. So in this case, it'll give us 1x or x on the left side of our problem. And then on the right side, we just have the number part of our answers. We can go ahead and multiply out 21 times 4 and divide by 1 times 3. So we get, what, 84 divided by 3. Or I was taught to cancel before we multiply, so I look for common factors. Like 3 and 21 are both divisible by 3. 3 goes into 3 once. 3 goes into 21 7 times. 7 times 4 is 28. 1 times 1 is 1. And 28 over 1 is just 28. Either way will get you to 28, and both ways are acceptable. Now, we do have a distributive property. Look at this. We have parentheses. So every time I have distributive property, I like to draw in my little arrows. So I can do a little arrow to the 5 to y and 5 to -6. 5 times y is 5y. 5 times -6 is -30. Add 30 to each side, and I get 5y equals -30. Divide both sides by 5, and y is -6. So whenever you run into that distributive property, draw that arrow in. It's quick and easy, and it makes all your problems come out right. Remember, we're taking the number on the outside and multiplying it to each number on the inside. All right, you guys try this one. Come back when you're done. We'll see how you did. All right, welcome back. We got some like terms here. 3x plus 2x is 5x. Minus 1 equals 24. Add 1 to each side. 5x equals 25. Divide both sides by 5. And x will equal 5. All right, last one. Let's give this one a try. Pause the video here and see how you do. All right, we are going to start with distributive property. Draw that arrow in. 3 times x is 3x. 3 times -2 is -6. Then we want to get 3x by itself. We want to get rid of this -6 that's on the same side. So let's add 6 to the left side, add 6 to the right side. Then I have 3x equals 18. Then my last step is to decide what's being done to x. Is x being added, subtracted, multiplied, or divided by 3? Well, in this case, it's being multiplied by 3. So I want to undo multiply by 3 with divide by 3. Divide the left side by 3, so I need to divide the right side by 3. And x equals 6. So I hope that helps you guys get started with some of the common problems you see with equations with multiple steps. Make sure you're doing the same thing to both sides. Make sure you're asking yourself what's being done to the variable and what kind of inverse operation would help undo that to ultimately isolate the variable. Once you get that variable on one side by itself, you are good. Have a great day. OUT spells out.